Okay, now let us consider we have a population of size n is equal to 5 numbers which are 3, 6, 9, 12 and 15. All these are first 5 multiples of 3, and then we can have we can have multiple samples of sample size which is represented with n of 3, and then we are asked to find out probability distribution for the sample mean, probability distribution of sample mean, which will be represented with x bar, and also sample median, which is represented as m. Okay, but first we need to know that what is the mean of the population and what is the mean of the population, also what is the mean and median of population, so that at the end we can compare what is our result. So mean of the population is represented as mu, and we can calculate it by adding all these 5 and divided it by 5. We get an answer of 9, and median of the population is represented with capital M, and it will also be 9 because 9 is in the middle, 2 on one side, 2 on left and 2 on right, so middle one is the median. So now let us find out the sample distribution of sample mean. How we are going to do it? We are told that we can have a sample, we can have samples of sample size n. So let us find out the combinations. I'll draw a line first, like this, and then another horizontal line, and then another line. This is for median. Okay, here it will be sample, and here it will be x bar, and here it will be m, median. Since we can have sample of size n is equal to 3, so our first combination can be 3, 6 and 9, and then second one can be 3, 6 and 12, third can be 3, 6 and 15, then 6, 9 and 12, then 6, 9 and 15, and then 6, 12 and 15, and also we can have 3, 9, 12, 3, 9, 15, then 3, 12 and 15, and we can have, I guess, one more, 9, 12 and 15. Let me increase this line's length. Okay, let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, yeah, we can have 10 samples. Okay, now we have to calculate mean of each sample. The mean of the first sample will be 3 plus 6 plus 9. Let me calculate it. 3 plus 6 plus 9 divided by 3 is 6. So its mean is 6. And then 3 plus 6 plus 12 divided by 3, it is going okay, 3 plus 6 plus 12 divided by 3, it is 7. And then 3 plus 6 plus 15 divided by 3, it is 8. And then 3 plus 9 plus 12 divided by 3, sorry, it is 6 plus 9 plus 12 divided by 3, it is 9. This one is 9. Then 6 plus 9 plus 15 divided by 3, it is 10. Then 10 plus 15 divided by 3, it is 11. And then 3 plus 9 plus 15 divided by 3, it is 9. Then 3 plus 9 plus 15, 3 plus 9 plus 12 divided by, this one was 8, and this one is 9, and this one is 10. And then 9 plus 12 plus 15 divided by 3 is, this one is 12. And 6 plus 9 plus 12. Okay. So this is the mean. This is the mean that we have already found, and the median is very simple. The middle one is the median in each of these. So here it is 6, 6, 6, 9, 9, 12, 9, 9, 12, 12. So remember that when you have to find out median, you have to write the samples in the means the elements of the samples must be in ascending order, so that you could find the appropriate middle one. Now we have to find out the probability distribution for each of them. So first, sampling the probability distribution, which will be called as sampling distribution, of course. So of the median, probability distribution of mean, like this. On x-axis will be mean, and on y-axis will be probability of the mean. Let me change quickly to this one, will be easier. Okay, so our range is from 6 until 12. Okay, 6, 7, 8, 9, 10, 11. 11 and 12, and the probability for each one is calculated as by counting all the numbers, means how many numbers there are: 1 2 3 4 5 6 7 8 9 and 10. So there are 10, so each of these will have equal probability. So 6, the number of times 6 is appearing divided by 10. So first one, how many times first one is appearing? 6 is appearing. Let me change the color. 6 is appearing only once. Then 7 is appearing only once. 8 is appearing 1 2. 8 is appearing twice, and 9 is appearing 1 2 twice. 10 is twice. 11 is once, and then 12 is once again. So the probability will be P of x, it will be 1 divided by 10 will be 0.1. So the probability is 0.1, and we can write it like this: 0.2, and then 0.3 and 0.4, like this. So 6 has a probability of 0.1. This is the probability of 6. And then 7 has 1 again. And 8 has 2, means that 0.2. Again, plot it like this. And then 9, it has 0.2 also. Okay, and 10 has 0.2 also. You can plot them like this. Width should be equal, the width of the column should be equal actually. And 11 has 1, so it's 11 is appearing only once, therefore its probability will be 1 divided by 10, 0.1. And then 12 is appearing once also, its probability distribution will be 0.1 also. So this is the probability distribution of sample mean, and this is also called as sampling distribution. So I leave the probability distribution of median to you, so you can plot that distribution yourself. Count each of those medians and then divide them by 10, because there are total 10 combinations or 10 samples, and you will find the probability for each. I can count here for you, and then you can plot it. 6 is appearing 1 2 6 is appearing 1 2 3 times, so 6 is 3. Then 9 is 2 3 4. 9 is appearing 4 times, and 12 is 3 times. So there are 3 only, so you can have 3 bars. So each of these 3, its probability will be, probability of mean will be equal to 3 divided by 10 equals to 0.3. It will be equal to 4 divided by 10 as 0.4, and again 3 divided by 10 is equal to 0.3. So these are the ones that you can plot. Let me make it easy to separate the graph from the values.